How do we calculate derivatives using the definition of derivatives? Well, first, let's agree that this is the definition of a derivative. Keep in mind you're going to be evaluating the limit normally. Simplify as much as possible. And it's important to note that we have multiple variables in this. We have h and x. We're letting h approach 0, not x approaching 0. So, calculate the derivative of this. So, we're going to take the limit as h approaches 0 of f of x plus h minus f of x over h. Well, no matter what, because of this function, no matter what we plug into it, we get out 3. So we get 3 minus 3 over h. And the limit as h approaches 0 of this. So we're going to get 0 over h, which is the same thing as 0. So the answer is 0. The derivative of this function is 0. Calculate the derivative of f of x equals 8x minus 7. The limit as h approaches 0 of f of x plus h minus f of x over h. So we have to plug in this in for x, and then plug in 8x minus 7 over h. Distribute 8x plus 8h minus 7 minus 8x plus 7. And this is all over h. 8x and 8x cancel, negative 7 and positive 7 cancel, and we're left with limit as h goes to 0 of 8h over h, which is the limit as h goes to 0 of 8, which is 8. And this is good because the slope should be the same as the derivative. And here, the slope of this line, it's a horizontal line, the derivative is 0. That's good. Here, we have the limit as h approaches 0 of f of x plus h minus f of x over h. Limit as h approaches 0 of, we take x plus h squared, x squared, and h. Now we have to square this. When we square this, we get x squared plus 2xh plus h squared minus x squared over h. Limit as h approaches 0 of x squared and negative x squared cancel. So we have 2xh plus h squared over h. Now, these h's can cancel. We can divide out the h, and we're left with 2x plus h. Now that we have it simplified completely, we can let h approach 0, which means that our answer is 2x. So if we wanted to find the derivative of that function, we would plug it into 2x to find the slope at any point. Calculate the derivative of this. So we have limit as h approaches 0 of square root of x plus h minus 2 minus x minus 2 over h. Now we can multiply by the conjugate in the numerator and denominator, which would give us x plus h minus 2 minus x minus 2 over h times the conjugate, square root of x plus h minus 2 plus square root of x minus 2. So the numerator, x's cancel, 2's cancel, and we're left with h. H over h is going to cancel, leaving us with square root of x plus h minus 2 plus square root of x minus 2. The h's cancel, which leaves us with the limit as h approaches 0 of 1 over square root of x plus h minus 2 plus x minus square root of x minus 2. And when we let h approach 0, we get 1 over square root of x minus 2, because this is now 0, plus x minus 2. And these are like terms, so we can say 1 over 2 square roots of x minus 2. Last one, calculate the derivative of this. So f of x plus h means plugging in x plus h where x used to be, minus f of x over h. Get a common denominator in the numerator, 4x over x times x plus h, minus 4 times x plus h. And that's all over h. This is getting a little ugly, but sometimes that's what happens with derivatives. Simplify these, 4x minus 4h, all over. This all combines to get xh times x plus h. These cancel, which leaves us with limit as h approaches 0 of negative 4h over xh times x plus h. The h's cancel, leaving us with limit as h approaches 0. Sorry, these are supposed to be h's, not n's. Negative 4 over x times x plus h. Now that we have simplified as much as we can let h be substituted in as 0. Negative 4 over x times x, which is negative 4 over x squared. So the derivative of this is negative 4 over x squared. That's how you calculate derivatives.